That's right. I'm back. Unit 3. Starting right now. Welcome, everybody. Welcome to Unit 3. And Unit 3 is all about sampling. What is sampling? Well, sampling is when you take a population and you take number of samples from that population. Why not just take the whole population? We are in a census year. Well, taking the census is difficult to impossible to collect every single individual from across the country. They try. But what statisticians more often do is they take a number of samples, not just one, but a number of samples, and then they work with that to give accurate estimates of the population. All right, so Unit 3 is all about sampling. Let's get to it. First, let's talk about the population. The population has a size of uppercase N. It always does. A mean of mu. The population has a standard deviation of sigma and a variance of sigma squared. So, statisticians dive into that population, and what they do is they take samples, not one, but a group of samples. Okay, so one sample, two samples, all the way down to k samples, and they get a bunch of sample means, x bar sub 1, x bar sub 2, all the way down to x bar sub k. That collection of sample means has a name, and it's the title of today's and this basic unit. It is called a sampling distribution, and specifically a sampling distribution of means. Okay, these collections of samples not only have sample means, but they also have sample standard deviations, S sub 1, S sub 2, all the way down to S sub k. This is also known as a sampling distribution. It's a sampling distribution of standard deviations. Okay, if we go further down the rabbit hole, let's just think about this for a second. Each of these sample means is a number. I'm making this up completely, but let's just say x bar sub 1 is 8.2, x bar sub 2 is 9.4. Let's just say x bar sub k is 7.6. I can theoretically take these numbers right here and take the mean of those means. Okay, so let's go to this statement right here. Each sampling distribution has its own mean. All right, in other words, if I average the 8.2, the 9.4, the 7.6, I get the mean of the means, in other words, and it's not called mu, it's not called x bar, it's actually called mu sub x bar. It's called the mean of the sampling distribution. And if I could take the mean of that sampling distribution, I can also take the standard deviation of that sampling distribution, those collection of numbers. But then it's not called the standard deviation anymore. It has its own name. It's called the standard error, and it's notated by sigma sub x bar, the standard deviation of the sampling distribution of means. Now, this all sounds very confusing and complex. It actually makes things a bit easier to understand. If you hear the words standard deviation, you automatically know, ooh, that's just the standard deviation of a population of data, all right, or just a sample of data. If you see or hear the words standard error, oh my goodness, that must be the standard deviation of a collection of means, a collection of averages. It's the standard deviation of the means. All right, still might sound confusing. We're going to get into this right now. Example 1. We're going to do 2 examples. Let me tell you something very important. These 2 examples are going to be worth up to 36 points on your next test, on test number 3. 36 points. The test itself is only worth 90 points. So these 2 questions alone are worth more than 1/3 of your next test. And everyone can do these and rock them out. So let's get it popping. A population consists of 2, 3, and 7. Consider all samples of size 2 which can be drawn with replacement. Find A, the mean of the population, B, the standard deviation of the population, C, the mean of the sampling distribution, and D, the standard error. Let's begin with A and B, the mean and the standard deviation of the population. We learned on day 1 and day 2 of this course that the mean is just the sum of the x's divided by capital N. So just take the 3 numbers in the population. By the way, no one ever said the population had to be large. 2 plus 3 plus 7, all divided by 3, and you get a mean of the population of 4. The standard deviation is just the square root of x minus mu squared divided by n. So just take each of these numbers, subtract by the mean of 4, square them, and divide by 3, take the square root, and you get 2.16. I would like you to try this out right now. Take these three numbers and put them into L1 of your calculator. Then, to find parts A and B right here, you do not need to calculate these by hand. You can do stat on your calculator, then go to calc, then do 1 bar stats on L1. A and B can simply be done using your calculator. These are the hand calculations that we learned back at the beginning of the year. However, use your technology to get them. All right. Now let's get to part C, the mean of the sampling distribution. Recall, we are considering all samples of size 2 from this population and with replacement. That means draw a number from a hat, then put it back in the hat. So you can draw a 2 and then another 2, or a 2 and a 3, a 2 and a 7, then a 3 and a 2, a 3 and a 3, and a 3 and a 7, a 7, 2, 7 and a 3, and a 7 and a 7. Ladies and gentlemen, if you can list all those samples out, you are going to get 6 points on the next test. I'm telling you the truth. If you can just make that first column of data, you're going to get 6 points on the next test. All right, speaking of those samples, how many should you get with replacements? Well, let's count them up here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 samples there. Interesting. Capital N, look over here on the left. Capital N equals 3. Lowercase n is 2. Doesn't 3 squared equal 9? It does, not a coincidence. When you are sampling with replacement, there are always big N raised to the power of little n samples, or in this case, 3 squared samples, or 9 samples. Is it something that needs to be memorized? Not necessarily, but is it extremely helpful in letting you know how many samples you should get? Absolutely. So, what will we do with these samples? Well, we're going to take the average of them. The average of 2 and 2 is 2. The average of 2 and 3 is 2.5. The average of 2 and 7 is 4.5. And when I say the average, I mean the mean. The mean of 3 and 2 is 2.5, and so on and so forth. The sum of these sample means is 36. So, to find part C, the mean of the sampling distribution, the formula doesn't change. I simply take this formula from part A and transpose it down to part C. Instead of the sum of the x's, it's now the sum of the x bars. Instead of dividing by capital N, you're dividing by the number of samples. But how many samples are there with replacement? There are big N raised to the power of little n samples, or 9 samples. The formula may look complex, but you're just simply taking the sum of all your sample means and dividing by the number of samples. 36 divided by 9 is 4. Okay? You're going to get 6 points on the next test if you can do part C. Last but not least for number 1. Okay, let's do part D. Now, what we learned back at the beginning of the year was that there was a definition formula for standard deviation, which is what you see in part B, but there was also a computational formula that we learned right beside it. You can go back in your notes and check. And the computational formula for standard deviation looked just like what I wrote here in part D. Okay, and so it's the sum of the x bar squares divided by the number of samples, which is big N to the power of little n, minus the mean squared. So if you notice here, we need one more sum. We need to find the sum of the x bar squared. So look at the table I created. I created a column of x bars, but then I also created a column of x bar squares. Just take your x bars and square them. 4, 6.25, 20.25, and so on and so forth. And the sum of my x bar squares is 165. So I take that sum of the x bar squares, 165. I divide by the number of samples, which is 9, and I subtract the mean squared, which I just found in part C, 4 squared. Okay, and I get 1.53. Ladies and gents, we just answered all of number 1. You are going to get, I'm going to repeat, 6 points. 6 points just for listing the samples on the next test. You are going to get 6 points if you can plug into this formula and find part C. And you are going to get 6 points if you could plug into this D formula and find the standard error. Crazy. I'm going to pause the video now and I'll do a part 2 and we will sample without replacement.